Here it is. This is the completed metal detector project. Search coil is all tied up, all put together down there. Got our 50 ohm coaxial cable going up here to allow me to extend or collapse the pole itself to whatever size I want. So at the control box, I ended up using a little plastic container, one of those little junk drawer containers, and it's an old container. It must have came from the 70s or something. Had it forever. So let's get a little shot of the signal intensity meter. I made a scale for that, printed it out, glued it to the back. Got our little battery indicator there, power button, volume tone, fine and coarse controls, and an RCA jack so I can unplug the coil and use different search coils. Now onto the insides. Got our battery holder right there. Holds two 18650s. See the headphone jack right there, and the main circuit and the power converter circuit. Left a little space right there in case I want to do any possible upgrade in the future. Speaker and the potentiometers and meter wiring all nice and snug. So I did leave a little space because I was thinking this circuit has a pulse speaker output, which is okay to listen to for a while, but I was thinking it'd be interesting to actually have a voltage controlled oscillator on the output. So instead of just hearing the buzz come through, the closer you get to a metal object, it'd actually increase in pitch as you get closer to a metal object, and maybe make that an option. So as far as the schematic goes, this one-handed here. Got it pretty much drawn up here. Try to give a quick explanation of what's going on here. This is the basic Russian Pirate Pi metal detector circuit. I redesigned it a little bit. I used the original 555 timer for the pulse generator, and I'm allowing it to control the threshold internal adjustment to really narrow it in for detection. Speed control, which is external, or that would be our tone control. I did decide to go with an IRF 740 because it has less capacitance on the output of the drain compared to the IRF Z44N I was originally using. Plus this can handle up to 400 volt spikes on the drain, so this is more suited for this application. I did use an MPN driver rather than a PNP driver because I trust this a little bit more, and it seems to draw a little less current somehow just seems more stable. Diodes, I'm going with the original 1N1418. Detector coil, I replaced 470 ohm. They originally had, I think, 390 ohm or something like that there. Drives the diodes a little less hard. Otherwise, I found this thing likes to eat diodes if you're not careful, especially if you disconnect the coil temporarily. So I made sure to give them a little bit more leeway. And onto the detector, I got for the sense internal trimmer, so that you can adjust exactly where you want the coarse and fine to start at for your main controls there. And on the output, instead of driving the speaker from the collector right up to positive, I decided instead to drive it through a capacitor, volume control, and then down to ground. I find that the speaker operates a lot better that way, sounds a lot better too. And also this works better for headphones that way too, which I added a headphone jack to take out the speaker when headphones are plugged in and go through the headphones instead. 10K resistor on the collector there drives up the transistor positive through the capacitor until the base gets over the initial bias point where it makes the pop, and when it saturates the transistor, the pops and clicks that go through then discharges through the capacitor, speaker to ground. And I know it seems a little odd doing it this way, but the sound is so much better. Sounds more crisp instead of more, just pops and clicks. And I find the more crisp sound to the output stage sounds a little bit more realistic, kind of like you're getting close to like a transformer or a high frequency pulsing, rather than just a click 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 like it was originally doing in the original Pirate Pi schematic. Second transistor here is basically like the first transistor stage in the original Pi, Russian Pi circuit, except the second transistor I'm also coming out. The original goes through capacitor to the base. This one also goes to a capacitor base. You can see it's basically a repeat of the same circuit, except this one is driving the meter. So it goes into the meter. We've got a protection diode across the meter, so the meter can never go above around 0.7 volts, so we don't fry the meter in case a large pulse comes through or something like that. And then of course an internal adjustment for the meter to calibrate the meter. I'll upload this schematic too in the future. Down here we got our buck boost converter, if you want to call it that. 555 again. We have an input protection shot key diode, which if you reverse the batteries by accident, which some people will accidentally do sometimes with the 18650 Li-ion batteries, it will conduct through the Schottky diode, blow the fuse. That way it protects the rest of the circuit. I'm using feedback through another transistor through the timer circuit so that it self-regulates the voltage. I find 10 volts DC for the rest of the circuit is about accurate. More than that's unnecessary, less than that it doesn't seem to detect as well. I know some people run this off of 9 volts. I like running it off of 10, 11 volts. And we got our battery low level indicator, which uses a TL431, and we also drive a Zener diode on the output, a high ampere Zener diode, to protect this in case this entire circuit gets disconnected from here. So that is where I'm at now, and in the future I might add an add-on VCO to the output of this as an option. So instead of pops and clicks, we'll get a frequency that increases when you get closer to metal. But for now, that's where it is. So one little quick note I forgot to mention is the batteries. I'm using two 18650s, which will give me anywhere between 6 to 8 volts. It should be around 7-ish volts. If it dips below about 6.2 volts, which I can adjust right here for the low battery indicator, where the battery light comes on, because we don't want these batteries to ever dip below about 3.8 1 volt a piece, roughly, maybe 3 volt a piece. If they dip below that, batteries can be ruined. So we want to make sure these never go below that. Together, that would be about 6-ish volts. We can set where that detects it and turns on the low level indicator. But yeah, we're taking about 7 volts into the boost converter, and then we regulate that and boost it up to 10-11 volts, which is settable via the internal adjustment there. And it will hold regulated for hours. I've had this metal detector turned on for approximately 4 hours now, and these batteries barely drain dead. So I don't know how many hours I can get off of 2 batteries in the field when I use this metal detector, but I'm guessing, well, at least 4 hours for sure. I'm guessing maybe 5, 6, 7, 8 hours I'd have batteries before I'd have to charge up the batteries. The other quick note on the 555 pulsing circuit oscillator, there is a trim pot. I didn't describe this too well. What that's doing here is adjusting the pulse width of the timer, because if we narrow in the pulse width, we can really adjust where the coil pulses are detected and how much we drive the coil with current to get the best current consumption and the best detection off of the coil once the MOSFET switches off and it starts detecting through that pulsing. So you definitely want to control the pulse width of the timer, which I know the original Pirate Pi circuit didn't really have that option. You could add that option, so I definitely did. It does make a difference. That doesn't really have nothing to do with the speed control. The speed control really only adjusts the tone, which is why I called it tone over here. So that's that. Just want to make those quick notes so that people know exactly what's going on with that. I did make one upgrade real quick to end this entire project for now. I upgraded the audio transistor output to a MOSFET MOSFET transistor. It gives a lot louder punch audio. I went from the original 2N5551 NPN transistor and literally just dropped an IRF Z44N in its place. Literally, base I ran to its gate, source I ran to its emitter, collector I ran to its drain, and the only other change I made was instead of the 10k ohm resistor up here, I went with a 2.2k ohm resistor. This will be reflected in the schematic that I will post later on, but this gives much louder audio without any sacrifice of how the audio sounds, because the FET switches on and off much cleaner than the original bipolar transistor. So there's that. You can see that there's quite a lot of modifications have been made to the circuit so far. Instead of a PNP transistor here, like a lot of the Pirate Pi metal detectors, I went with an NPN. I did eventually go to the IRF 740. I was originally using an IRF Z44N, but this will handle voltage better and it seems to work a little bit better in the detector circuitry. Of course, the ability to change the pulse width makes a huge difference in detection quality. And then finally, the audio stage is now an MOSFET transistor also. The only thing this not is the bipolar that's being used for the meter, because that's not required for the meter. Draws no more current. All this, well, besides, unless you have full volume, it might draw more current now because it's capable of driving the speaker louder. So I found that outdoors, this entire metal detector was a little bit on the quiet side. I had to use headphones and the camera could barely pick it up. Now it's just loud as can be if I crank the volume up. And I'll probably have to replace the 5k ohm resistor for volume with maybe a 200 ohm variable resistor, which I don't have at the moment, so I'm just going to stick with the 5K, and I'll replace that down the road with maybe a 100 ohm, 200 ohm, maybe a 1K resistor, variable potentiometer, because the 5K, it just gives very little play at the very end of it. So yeah, that's going to finish this video for now. Any questions, leave it in the comments, and I'll be happy to answer. I will get the schematic up as soon as possible. So, thank you everybody for sticking with the project and watching.